Hello, everyone, and thank you very much for the tuning in to the Cloud Native FM podcast. This is my first episode. I'm actually recording in 2025 as of January 8. In today's episode, we dive into the world of WasmCloud, the Wasm component model, and their growing influence within the Kubernetes ecosystem. WebAssembly promises portability, performance, and security. But how does it shape the landscape of computing in cloud and cloud native application that a question everybody wanted answer from? So I have wonderful guest with me. So I go straight to my first guest. I believe is the co-founder of Cosmonic, Liam Randall. Over to you, Liam. Can you tell us where you are and how's your new year going by?
It's off to a great start on the podcast today. Thank you very much for having us. My name is Liam Randall. I'm the co-founder of Cosmonic and co-creator of CNCF WasmCloud, recently incubating. I've been a long-time cloud native contributor and did the very first Kubernetes company commercially in 2014, Critical Stack. And then I went on to play a role at Capital One and their transition into taking the first highly regulated organization into the cloud.
My new year's been fantastic. Very, very busy. We have a lot going on here. I'm the CTO at Cosmonic. I also serve as the technical steering committee director in the Bytecode Alliance Foundation and also the recognized contributor rep to the board. And part of those roles is working on building some of the foundational type projects for WebAssembly, including runtimes, tools for making it easy to compile to Wasm, etc. And all of that's built on secure foundations. I also serve as the chair for the WASI subgroup within the W3C's WebAssembly community group. And that's where we're working towards coming up with ways to make WebAssembly run amazing outside of the browser. So that's a little bit about, the tech side, I guess. I live in Raleigh, North Carolina, and I've had the privilege of working with Liam for the past several years, starting before that at SingleStore, which is a database company that also had some involvement with WebAssembly. So I feel like right now is just an incredibly exciting time seeing adoption across the entire ecosystem.
Totally. So I will ask first question to you because you are actually, I think I learned recently or heard somewhere like that you actually selected for the second tenure in your role in the, and you need to tell us what that role is. And also, I think the first question in 2025, everybody is looking forward to what is the state of ecosystem, WASM ecosystem today?
Bytecode Alliance holds elections every basically end of year, but what roles get replaced on the technical steering committee? You served for 2 years, so I got reelected to serve another 2 years, which is a really great privilege. Yeah, and so that just occurred, and we're about to kick off the next technical steering committee meeting. The types of things that we do is trying to build out the roadmap for what we do throughout the year. The roadmap for this year is actually incredibly ambitious. We are working towards building out WASI P3, which is the next major iteration of what we build with the WebAssembly component model, and then WASI. WASI originally stood for the WebAssembly system interfaces, but it's a lot easier to understand if you think of them as the WebAssembly standardized interfaces. And essentially, those are modular interfaces that make it so that you can access HTTP and sockets and the file system and all these other things that before with a core WebAssembly module that is sandboxed, you did not have a standardized way, aka a way that other runtimes were providing those capabilities to you.
News. I think I would definitely look forward to WASI P3 as well because I think WASM ecosystem in general and interfaces are actually developing very rapid space. I think back then, 2 years back then, I think not enough languages support WASM or the WASM interfaces. Now I don't see a language that doesn't support it. That see the community is an actually 24/7 working tirelessly to make sure the Wasm become more accessible to a lot of developers and a lot of startup and enterprising who are running businesses out of it as well. So now I go to the Liam. I think usually when year start is developer want, if they have listened to Wasm, they need to understand what is my developer workflow if I start incorporating tomorrow in my delivery pipeline or in my development cycle. So what is the Wasm developer workflow today?
That's a great question. I think what people have heard about the properties of WebAssembly for a few years. They understand that it's a smaller way to compose software. I like to think of it as building Lego blocks for software. It works incredibly well with platform engineering because it sort of restores this order where platform engineers can help developers to maintain and scale their applications more readily when using a platform like CNCF WasmCloud. Now, traditionally, WebAssembly has been very hard to use. When you go back a decade, the standards were very early, and you needed to understand the right incantation to get WebAssembly to work. But the entire community has been very hard at work collaborating with compilers and language runtime teams like TinyGo and Big Go upstream in order to enable a very idiomatic experience. So if you go to the CNCF Wasm Cloud Quick Start now, what happens is writing using Go for building WebAssembly components feels very much just like using Go. The Go STL is supported, and you're able to simply just write Go, and then it compiles seamlessly to WebAssembly in the background. That experience, when we say idiomatic, what we mean is that it's an experience that's native to that language toolchain, seems to be one of the keys to really unlocking WebAssembly's potential for the enterprise. In this year, Cosmonic will be working with a few other companies in order to help advance support for TypeScript, for example, as well, and make sure that we've got a really idiomatic experience for TypeScript. So developers that are experienced TypeScript or JavaScript engineers simply can write code the way they always have, and in the background, we're able to compile it directly to WebAssembly components. Now, once you have a WebAssembly component, the very next thing you need is a way to organize, run, and scale them, and that's where CNCF Wasm Cloud comes in. Wasm Cloud comes out of the box with support for most of the popular platforms today, including Kubernetes and all of its managed derivatives. It works by using and leveraging your existing investments in Kubernetes and making and enabling WebAssembly to run efficiently on them today. So what Wasm Cloud will do is Wasm Cloud will take a collection of components, think like a box of Legos, and you can organize them into an application that Wasm Cloud will scale seamlessly to meet the application load and then back to zero with zero cold starts. It integrates in so your existing Kubernetes primitives work. It ships out of the box today with a Kubernetes operator, a CRD, and we typically see people deploy it, deploy their components through, Argo or some sort of GitOps solution. Out of the box, it ships with common integrations for all of your popular secret stores. Think HashiCorp Vault, AWS Secret Manager, Kubernetes Secrets, and has instrumentation for things like OpenTelemetry.
I think that's a great news for the listener as well, because back in the days, as I mentioned earlier, there's a lot of plumbing required for the Wasm to workflow for the languages. And now the component model makes it very smoother experience. I think the component model, I can see that in the Kubernetes runtime interfaces. Like if you work in the Kubernetes, you have a CRI, CNI, CSI. Now the same has been the methodology being developed for the Wasm for the component model. So I see there's no reason why more and more languages and runtime can have smoother experience for the developers as well. But I now go back to the Belly. And Belly, can you tell us, because we talk about Wasm Cloud. So can you tell us a bit about your experience of how Wasm Cloud is actually originated and what it meant for the developers and the community overall to be a CNCF incubated project?
Absolutely. I'm a maintainer on WasmCloud, but Liam was one of the founders of it, along with a handful of other folks out of Capital One. And that's where a lot of that open source work started, and it was contributed to the CNCF, gosh, I think about 5 years back. And it's had many different iterations because the what you could do with WebAssembly has changed over time from the standards advancing. Specifically for the WASI side of the world, those standards have advanced quite a bit, but also from the core WebAssembly specification. A lot of the things that have been done there have enabled us to be able to compile new languages, like the WebAssembly GC spec proposal, which is now landed in Node.js and Chrome, and also now in Wasm time, which is the runtime that we use within WasmCloud. So folks are really excited about WasmCloud and use it as a way to run most of their sort of backend microservices, but they're running them as WebAssembly components, which has a ton of advantages. Some of the biggest ones would be that you just write and focus on your application code. You code to these interfaces. These are interfaces that have strict types. It's built with WIT, which is part of the component model ecosystem. And essentially, you deploy this in a WIT native way. We have a WIT native orchestrator that deploys this out to a WebAssembly host. That's a WasmCloud host that embeds Wasm time. And essentially, you're able to build and compose and extend what is available by your platform at runtime. And so the reason why folks are excited and use WasmCloud today is that it makes it really easy for you to run on Kubernetes, on bare metal, and all of these different environments in a native way for those environments, but also in a WIT and WebAssembly component native way.
During the KubeCon Salt Lake City, the announcement has been made that the Wasm Cloud become a CNCF incubated project. And during that time, I've seen who is the best guest for me to speak about this stuff. And now I have a guest with me, so that's a great thing. And I think the Wasm Cloud allows apps to operate resiliently and efficiently, and ability to run Wasm binary is the same for any environment, cloud, on Kubernetes, or in data center, or at the edge. That I think is a very unique piece that we're actually looking forward to. So I think I now go back to the Liam. Liam, can you tell us what is actually today happening, and what is the plumbing, or what is the things required to run Wasm in the cloud, and how much the investment has been happening to make Wasm accessible in the cloud environments?
Right. Absolutely. The great thing about CNCF Wasm Cloud, or possibly the best thing about CNCF Wasm Cloud, is the community. When we think about the number of things that you need and the number of integration points that you have around a cloud native software, what you end up with is a very many-to-many situation. When you think about the common tools in the cloud that we use to build components, we think about secret stores and databases and message queues. We think about HTTP. We think about messaging. Those interfaces are the common building blocks that make up almost every application. And then we think about all the places that we want to run things in the cloud. Now, the sad reality, or maybe just the reality is, it's not sad, is that most compute is still on-prem. Now, it could be on-prem running in Kubernetes, or on-prem running on OpenShift. But the best thing about CNCF Wasm Cloud is that the community has built a huge number of these integrations that enable you to run on any cloud edge, including your own. So when Bailey was walking through the sort of steps previously, developers start by building WebAssembly components, which you just start with your Go code, for example, or your TypeScript code, and you compile directly to these building blocks. Using CNCF Wasm Cloud, you can define them as applications and even hot swap components later, moving between standard interfaces like messaging across different implementations of messaging, or standard implementations of key value to different implementations. You might be on Redis today and decide to use a Valkey or AWS Elasticache. So those things become very pluggable. And then when you install Wasm Cloud and the Wasm Cloud operator onto Kubernetes or onto ECS or Google Cloud Run or OpenShift or wherever that you'd like to run your apps, you now have the ability to scale different pieces of your app across many different places. So intellectually, it starts to look a little bit like this. I can build building blocks out of many different languages. I can run them on many different places, and then powerfully, developers and platform engineers can collaborate across their enterprise to decide where and when we choose to scale these applications. And what it means to the developers is that we finally have this next big abstraction in technology where when we think about the friction from the last few years, there's been a gulf, a gap between platform engineering and developers. And we've tried to cross that gap by giving developers a golden template, which in many ways has become the sort of original sin of platform engineering. As soon as a single development team copies that golden template, we end up in the worst case world. You know, in a large company, we might have 5,000 unique teams that each patch one vulnerability one time. And what we really want is a world where one team can patch 5,000 applications at once. And that is what the WebAssembly component model enables. And it brings sort of order back to the relationship between platform engineering as well as some of your developers' tenants.
Absolutely. And I think you make a wonderful point because when you work with a container, sometimes you add extra stuff you doesn't need, and then there's a vulnerabilities exploit and the explosions comes up. And then you realize you need to actually work out to make a zero CVEs. That is a huge investment of the time. With WASM, you can go away with the container nightwear plumbing, I can call it, because now it's boot up instantly and you can run it anywhere. And as we're progressing toward the WASM become a universal binary that can run in edge, cloud, and anywhere, I think this could going to be a developer heaven as well. So what I see is the WASM cloud simplifies the development experience by providing capability provider which abstracts common tasks like messaging, storage, and authentication. Developer can focus on business logic while Wasm Cloud handles the infrastructure details, making Wasm adoption faster and more accessible. Now, the next portion is we talk about is WebAssembly component model. So I can go to the Bailey and tell us how are many component exists today and how these components actually working in the real world use cases you have encounters in community and some of your customer interactions.
Absolutely. Yeah. I think to start, maybe we should define what the component model is. Inside a WebAssembly module is the core WebAssembly spec. That is basically a binary format. It is it's very compact. It's where we do all of our compute. So if you were to take that WASM module and print the WAT is the WebAssembly textual format of that. So let's crack open that module and see what's in it. Well, what you would see is essentially I32s, integers, basically as far as the eye can see, because it's just pure raw compute. The other thing that you can do with a core WASM module is you can give it a host function. And so you'll see a little import statement, and that's like how you could give it a handle. In theory, if you rolled your own, you could roll your own way to access a file system for the host that embeds the runtime and then like creates a host function that natively knows how to do that work. And hopefully you did it in the right way to sandbox it. And that's where WASI P1 came in. WASI P1 was based on just the core WASM spec, but it was also effectively an ABI. It was a monolithic ABI with WASI P1. That's not the case with WASI P2, but with WASI P1, we said, okay, well, hey, here's a way to expose a file system with these essentially these capability handles that plug into those host functions. And what's really interesting and compelling about that is then you have like this common way of making sure that when you're exposing a file system, you're thinking about exposing a capability. And so that, in a lot of ways, is built on the principles of capability-driven security. And that's one of the key benefits of being able to work within a standards body of doing this, and also making it so that many other runtimes and languages can target the set of APIs, and then you kind of uplift the whole ecosystem. And that made it possible for us to basically end up in a world where Prime Video, Disney Plus, us and Zoom right now, essentially everybody is able to be very productive in building WebAssembly and running it in many different contexts, not just in a browser context. However, this is a monolithic API. And which such very challenging to kind of grow it. And then the types of APIs that you would want to provide this type of compute changes depending on where it's running. Sometimes you might be running on the edge. Sometimes you might be running in a data center. Sometimes you might be running in a database, like literally in the query processing engine in the database, which is something that I got to work on a few years back. But so how do you set it up so that you're just giving it modular APIs, right? You're setting it up so that I can define those. And then there was this other thing that the community was really pushing for, which was being able to link these modules together. And so Luke Wagner is largely the key designer behind the component model. And so when you think about the component model, it's essentially a wrapper around the core WASM specification. And when I say a wrapper, I mean like almost literally, because let's go back and now we've compiled a WebAssembly component, not a WebAssembly module. If I crack that open and I'm looking at the WebAssembly textual format, what I will see at the top is component and no longer module as the first 8 bytes. And it actually will inside have a core WASM spec. So it'll say core module in there. And then below that, I32s, as far as the eye can see. But the new thing that is added is that the component model has this essentially metadata, but information about these modular types, these modular interfaces, structured types. So now I have things that are like strings and records and enums and all of that type of stuff around the way that I'm working with that core module. And so what that means is that I can take 2 different languages, let's say Rust and Python, and I can compose them together. And the component model gives me the ability to lift and lower types so that I can have these 2 components talk to each other. I link them together in a way that does not share memory. So each one of them has their own linear memory. So I still get that amazing sandboxing property that everybody needs from WebAssembly, while also being able to have the interoperability of this component model system, aka compositional system, and I can run all of this in the exact same process now because it's safely sandboxed. So that basically means that I can have 2 totally separate languages, 2 totally separate components or modules talking to each other in nanoseconds because it's all in the same process, which is really, really incredible.
Bailey, I think you have invested so much time creating some really great images to explain both of these concepts. I actually dropped you a link in your Slack. Would you mind maybe running through a couple of those? Because I think that they really just bring the whole topic to life. When you talk about what are WebAssembly components, maybe start with that link and share your screen. I think that would just really help, be so powerful to help the listeners at home that are maybe a little less familiar with the semantics of compilers and compilation, to walk through that. And then after that, maybe you could do the same thing with WebAssembly system interfaces. Because I think your infographics are so great. You're on mute.
Billy,
Yeah. I tell you, we could probably cut just a minute of that if you just go right back to the slide and then start with the simple, what are WebAssembly components? And you're so deep in the text sometimes. I think you don't realize how fast you go sometimes.
Yep. Sorry about that. Okay. Yes. What are WebAssembly components? Well, in a lot of ways, a WebAssembly component kind of looks like this, where it has interfaces that are imports. Those are the things that look like little nubbins going in, and then at the bottom, an export. So that's the things that you can call in a component to be able to, call into it, like a library, or maybe you're calling it and you're calling a run function and you're telling it to execute. So a component cannot instantiate if all of its imports are not fulfilled. So an easy way to think about WebAssembly component imports is that they are sort of your dependencies. I need the ability to log, log messages. I need the ability to connect to some type of key value store. And if I don't have that, I can't run. Whereas the exports are maybe things that you can come into and expose as sort of uh, similar to like how you maybe would be exposing a REST API. And maybe that's actually what it is doing. Maybe it's using WAS-HTTP to expose a REST API. But underneath, it's still just the same core WebAssembly specification that is the piece of the compute. And so in a lot of ways, you can think of the component model as the glue between other core WASM modules. Now, one other detail here is that WebAssembly components can have multiple core WASM modules inside it, and a component can have components. And so you can imagine like a sort of a more in-depth tree structure here, but you essentially have sort of the basics. This is when I talk about cracking open a core WASM module or a core WebAssembly component. This is the WebAssembly textual format called WAT. And so the WAT for this component essentially looks like this. It says at the beginning, hey, I'm a component, so parse me like a component. In the middle here, you'll see that we have that core module. And then you have both imports and exports at the end, as I talked about before. And what that gives you is the ability to compose across languages over these strictly defined interfaces. That language interoperability property where I have different, let's say, string representations between Rust and Go. The way they represent a string type is different. So how do I pass that from component A to component B? Well, the component model gives me the semantics for how to do that. I lift and lower those types. Basically, I go from what I know inside my Rust module. I take that type, map it to a core WASM type, and then it gets brought back into the other component here and sort of lifted to the way that you would represent that with Go.
So,
So, yeah.
yeah, another way might be to say that, if you have a string in Go, it's the same as a string in Rust through the magic of the component model. Or if you have, a struct or integers or other data types, that's what we mean with that lifting and lowering, so that you can do this really fast composition.
Yeah, and it is incredibly fast in that you do this composition, you do it ahead of time statically. You can do it essentially as part of your CI build process, or maybe you have a process for deployment and you do it at deployment time. But essentially, this is a static linking that is over, we call it shared nothing linking. And when I say that, I mean that the memory from each component, when I compose them together, is not shared between them, but it's still actually able to run in the exact same process, which is why you have this incredibly fast execution.
So at the end of the day, I'm expecting this, like if we live in the developer space, we need a translation sometime from language A to the language B. And that is sometimes good, but it's a very time consuming task. But with this approach, I can see a significant advantage, significant time for the developer, they gain for the development efficiency rather than translation layer between both two languages.
Yes. What it essentially will work out to be is that you write in the language that, is best for you, best for solving the problem space that you're in. Maybe you've got the libraries that you're most comfortable with and frameworks. And your platform engineering team can write another component that I call it a platform harness component because I'm most often seeing platform engineering teams adopt this pattern. Luke Wagner, who I've mentioned before, he calls it the donut pattern. And if you can imagine just getting like a hula hoop kind of wrapper around your component, that's essentially what we're talking about. So if you can imagine a platform engineering team, let's say, writes their platform harness in Rust, it's very efficient. It has all of the guardrails that is needed for this platform that they support for, let's say, the right way to fetch secrets, the right way to do a lot of the middleware work across their environment. And the component that the developer writes, they just focus on their business logic. And that's where we see a lot of the efficiencies for folks compiling and building for WebAssembly is that, in conventional ways of building with containerized applications, you may have the platform engineering team providing a base image that has a lot of that in it. And then they're kind of on the hook for managing that. And then this is where things kind of get smushed because you've got your developer team then building on top of that base image, and they're kind of floating around with the same system dependencies, same system libraries, same environment variables as the platform engineering team. Maybe things get conflicted, that kind of thing. And if the developer introduces more dependencies, then they're on the hook for managing and maintaining that. Versus this model where it has that right level of separation, but as a deployable unit, it's together. So you get the benefits of what we were trying to do with base image templates, but with so much more efficiency and being able to just own actually what you actually are supposed to own, and be able to update that independent of each other.
Yes, that's a great. I think I definitely look forward to. I think this requires a podcast in itself, and I will look forward to having more conversation on that front as well. Because with that approach, I would love to go back into my development time because I have spent year fighting with translation layer between the two languages as well. But unfortunately for this podcast, we have very small time left, so we haven't talked about Cosmonic. And I will definitely host Liam in the near future to tell us what Cosmonic does and what is actually doing. But before we let off in the next 2 minutes, can you explain in a very small amount of time what is Cosmonic today? What are your customer base and what are the problems you're solving today? Liam, over to you.
Absolutely. So, we've talked a lot today about the sort of first two layers of what does it take in order to get WebAssembly going in your large enterprise today, or even in a small enterprise or startup. It starts with the standards, which are W3C open for everybody. And then it helps by coming right to the CNCF, the home of all the world's greatest software, where we have platforms like CNCF WasmCloud. And oftentimes, you'll want a partner that can help you to adopt WebAssembly components and builds the tooling for enterprises and companies to scale this adoption throughout their enterprises. So Cosmonic builds a product called Cosmonic Connect. And what Cosmonic Connect does is it is a product that is built for platform engineers. It's loved by developers, and it is trusted by the enterprise in order to help organizations scale technologies like WebAssembly components and CNCF WasmCloud across any of their existing control planes. So we work with some of the largest companies in the world right now, as well as some of the smallest companies in the world, little tiny startups. And we help them to build and migrate their products. We improve the community tooling along the way. Cosmonic has always been committed to open source. We are one of the leading contributors to CNCF WasmCloud, although CNCF WasmCloud today has somewhere over 320 unique contributing companies when we look at the sort of member community that's out there. So if you are at a company and you understand today that WebAssembly has the power, its fast cold starts, its ability to cut cloud costs, its ability to help developers to build and deliver software faster. If those are problems that you're struggling with in your company, and you recognize that while containers are powerful and we'll be using them for a while, there are more advanced ways to do those things. Cosmonic is your partner that's aligned to your interest.
So, Billy, can you please tell us what is the prediction for the Wasm in 2025? And what can we expect from Cosmonic in the Wasm landscape?
Yeah, in 2025, big things. First up, I would expect us to see the next iteration of WASI land called WASI P3. That's going to give us native async, so we can compose via structured concurrency, which is going to be really powerful. I also expect us to have more language adoption. I'm expecting, for example, Kotlin to really start getting to the point where we're going to see many more Kotlin WebAssembly applications. And for Cosmonic, we're going to be launching our latest version of the product. I think you'll get to see a version of it if we run into you at KubeCon London. I'm really excited about it. We're rolling it out with several of our customers right now, and by the end of the month. And I think for the most part, what I'm excited to see is not only people beginning to adopt WebAssembly, which we've been seeing over the past 2 years, and instead this year is going to be very much about scaling their investments in WebAssembly.
Awesome. I think that's great news. I'd look forward to the Kotlin WebAssembly convo in this near future as well. I've been investing a lot on the .NET and the Wasm convo for the WASI interfaces as well, because I've spent a lot of time in the .NET background as well. So I've been experimenting as well. And Liam, it's up to you now. Give us a 2-3 key takeaway from this conversation. People who are just actually explore today what Wasm and WasmCloud is.
Yeah, I mean, I think the big news for WebAssembly is that it's finally ready for you to adopt WebAssembly today. It can make a huge difference in your cloud costs, in your developer productivity, and empower you with new capabilities for running your software on any cloud or edge, including your own. At the past KubeCon, we had incredible talks from companies that the world knows, like American Express, from companies like Adobe, from startups at previous KubeCons like Machine Metrics. And these companies are the best references for WebAssembly that you can have, because they're you. They're developers, they're companies, they're enterprises that honestly don't really care about WebAssembly, and their customers don't care about WebAssembly. But what they care about is a software that's delivered quickly, that software that has low cost, that software that's reliable and available. And those are things that WebAssembly helps you do today. So we really encourage you to join our community. It always starts with open source and building better together. So please feel free to join us at wasmcloud.com. If you click just down the right on the homepage, you'll find a Join Us on Slack button. You're welcome to come on in and join. And I'm sure that there's companies just like you, whether you work in government or in telco or in software as a service, or you're a hot startup. The community is gigantic, it's collaborative, it's helpful, and it's the kind of community that I'm really proud to be a part of.
Absolutely. And WasmCloud is an incubated project in the CNCF. This means the foundation, the new vendor neutrality is all these in there. And so many companies are contributing into it as well as an incubated project. So you must take a look at it. And I will make sure I will make Liam and Billy busy this year with me on doing this podcast style conversation in this future as well. So I do a follow-up recap for myself as well. The beauty of Wasm lies in its portability and sandbox capabilities. It allows developers to write code once and run it securely across a variety of environments, from edge devices to multi-cloud deployment. And Wasm modules are lightweight compared to the container, and they start up almost instantly. It encourages modularity. Instead of writing monolithic application or tightly coupled microservices, developer can compose application from reusable Wasm module. Each module can be sandboxed and independently updated, which improves both security and maintainability. And Kubernetes is fantastic for orchestrating container, but it's not always the best fit for lightweight workload. And WasmCloud allows developers to run distributed Wasm application without being tied to Kubernetes, but it also integrates seamlessly if you want to combine the two. With that, I hope you enjoyed the conversation and look forward to looking up the Cosmonic and all the information into the YouTube chat description. If you have more questions, remember these are the best people for you to answer all those queries. I will be keeping an eye out, watch a look on the Cosmonic, what they have been doing, and I will make sure to have more conversation with Belly and Liam in the near future. Thank you very much for joining the conversation, and we look forward to what is coming up in the near future in 2025. Have a wonderful day, everyone, and bye-bye.